Good evening, everybody. Welcome back from the break. My name is Adrian, and I'm the coach of the Carnegie Mellon University team. Before we begin our presentation, I would quickly like to introduce our customer to you. This is Professor Vivian Loftness as well as Paul Schmiedmeier. Furthermore, our project leaders are Dominik and Florian, and we have 9 awesome developers without whom this project would not be possible. And now they will show you how they successfully integrated fog computing as well as augmented reality into a smart office environment.
Thank you. In order for you to understand the problems that we were faced with, I'd like to shortly introduce to you the Carnegie Mellon University. It's located right on the east coast of America in Pittsburgh, Pennsylvania. On campus there, we have this building, and the top floor is known as the Intelligent Workplace. It's called this because it's a large office space with many smart devices. They're all connected to the network, and usually these devices are connected in a sort of controlled using an app and a sort of displaying the devices in a kind of list. So you have lamp 1, lamp 2, etc. Now, while this approach may be effective for a smart home, when you have your own devices, you know where they are, and you can name them accordingly. Here we have the situation where we have a lot of students that are coming and going all the time, and we have a lot of lamps. We have a bunch of sockets you can control, radiators and shutters, and so it can kind of be overwhelming if a new student wants to control the lamp that's right next to him on his desk. Let's say in this case it was lamp 5. I don't think anybody here can see it, neither can I, and yet it was there all along. So the second part of this is that the CMU really wants to raise energy awareness. So they want their students to start reducing their energy consumption. And in order to do that, they have to know how much they're consuming in the first place. So this brings us to our vision. So take Paul. Paul is a student who's working at the Intelligent Workplace every day. So obviously, he wants to be able to control it, including all of the devices that can be controlled. Now, he doesn't want to have to look around to find which device he can control and where. He wants to be able to see it and do so easily. So our product, IW Control, will allow him to see all the devices in his immediate vicinity and control them using augmented reality. Now, of course, Paul has a great sense of morality. He wants to reduce his energy consumption. And in order to do that, he needs to know how high is his personal energy consumption, and also including a sort of comparison function between different groups would allow him to see how he's doing in comparison to the average user or the worst user. So along with these visions, we were given certain requirements that our app should give. First, our app should be able to track energy consumption. Also, we should utilize location awareness to implement additional features, such as if an occupant is leaving the workspace and maybe he forgot to turn off a lamp or something, these should be turned off automatically. Also, we should be able to add new devices to our smart environment, as well as discovering and controlling devices using augmented reality. Now, before we get into our live demonstration, we'll have a little look behind the curtain with our system design.
Okay, so as you have already seen, there are many different devices of different types in our intelligent workplace, and controlling them one by one can be overwhelming. So we need some central instance to control them, for example, a cloud database. But this is also not optimal, because if I want to turn on the desk lamp right next to me, sending a request to a server miles away, and the server sending the request back to the lamp can be, has a long time. And so we added an intermediate layer, which we call the fog layer, between the edge devices and the cloud server. These fog nodes create a fog area containing themselves and the edge devices. And each fog node is also running a little database containing information about the devices in their own fog area. So you can control all those devices directly via the fog node and omit the way to the cloud, which reduces network traffic and latency times. Also, if the fog node loses the connection to the cloud database, you can still control all the devices around you until the connection is back on. Now we simply add another device to this whole system, which is an iOS device running our IW Control app, which then connects to the nearest fog node, joins the fog area, and you're ready to go. Let's see how this works in our live demo.
Ah, man, it's too damn dark here. I can't read. Excuse me?
Yeah?
Do you use IW control?
Yeah, duh.
I noticed my lamp hasn't been added to it yet. Maybe you could show me how to set it up?
Sure, the setup's pretty simple. Just click on Add, and then place it to the right spot. Then save it. And since we're both using this lamp, I'll set it as a shared device. Obviously, it is a lamp, and it's a Livix lamp, so we can use the predefined setup. And it's done. You've added a new device.
How can I turn up the brightness?
That's pretty easy as well. Just go up and down to dim the light. Also have a look at those little symbols. They are suggested preset brightness settings for different activities, such as working on the PC.
Well, since I'm reading Harry Potter, I guess the lightning bolt must be the perfect setting.
Whoa, if you keep that up, we're going to end up being the group with the highest energy consumption in the workplace.
What? It tracks energy consumption too?
Yeah, it does. We're all about being environment friendly here. Let me show you.
Okay, let's stop there for a second. So how does this work? Let's say Paul wants to turn on the light next to him. So he opens the IW Control app, which then sends information to the fog node containing information about the device, the action he wants to perform, like turning it on, and an identifier of the user, in this case, Paul. The fog node does two things. It turns on the lamp and sends this information to a cloud-based time series database. In this case, we want the database to be in the cloud because Paul can move freely around the workplace and switch between different fog areas, but still wants to get his total energy consumption. If he wants to retrieve his energy consumption, he opens IW Control and, for example, chooses his personal energy report. Then the fog node retrieves all the data from Paul from the time series database, which sends it back to the fog node. The fog node then performs the energy consumption calculation, so it just has to be one call to the cloud database and sends it then back to the app, which displays his statistics. So now move on with our demo.
The app tracks our energy consumption and go to the statistics to have a look at it. To see your personal consumption, you just go to Me, and there you see the consumption of today, the week, and the month. Let's have a look at the week. Oh, seems like you haven't consumed any energy on Sunday.
No, I never work on Sundays.
But you have the iPraktikum.
Not even for the iPraktikum.
Oh. Well, okay.
Anyways, you mentioned the group comparison thing. Where can I find that?
Just go to back and click on My Group. A group are devices shared by people of different areas of the workplace. And your group is highlighted. For example, we are Conference 2, and we are in second place.
That's pretty nice. And also, as we're a group, I guess nobody can see that it's me, personally, who's using all this energy, am I right?
No, but I swear, if we end up being the worst group in the workplace, we're going to have a serious talk.
Well, I guess then I need to turn off some devices now. Thanks and see ya.
See ya, bye.
So let's wrap up shortly where we stand today. Until today, we managed to set up all the necessary infrastructure to let all our components talk to each other, with the only exception that the location-aware features are still missing. We did implement fully discovering and controlling our devices using augmented reality. Besides of that, we also achieved to implement a basic version of the energy consumption analytics. The more advanced ones are still missing and ongoing. What we did else is implementing the functionality for adding new devices. It sounds actually pretty easy, but we had to write our own protocol for our light bulbs according to the specifications of the light bulbs manufacturer. This took us quite some time. But we finally managed to get this done until today. We also had to be very agile. Originally, we were supposed to deploy our FogNode program on a Raspberry Pi, but at a later point, we figured out that the Swift library is not yet fully compatible with a Linux-based system. So we finally moved to a Mac Mini, which resolved a lot of these problems. Letting the past behind, speaking about the future. In the future, it will be possible to add personal features like creating a personal profile for pre-configured values, as well as support of other device types, additional energy comparison methods, and the location-aware features. So that's it from my side, and I would now hand over to our two customers. Thank you.
I want to start by saying thank you to the TUM team. This is a decade-long partnership with bachelor's and master's and PhD students at Carnegie Mellon with Ben Bluke's team at TUM. This is awesome work. It's extremely important to be able to go into a workplace and identify what points of sensor and controls are available. All right, just anyway, I wanted to say thank you to this team. This is an amazing accomplishment. You know, most office buildings will have 2,000 points of control and an equal number of sensor points. And when you walk into the building you're in, it's very hard to figure out what you can control and how you can control it. So the advances of using the fog computing interfaces and allowing end users to simply point at an object and say, can I control this, is a real contribution. I want to thank this team for outstanding work.
Thank you so much.